So we go straight to some more examples. One. Redefine the following. By removing the absolute divide. One, f of x is equal to 3x plus 4. 2, h of x is equal to x minus 1 plus 3 plus x. And then 2. Complete the square. Of f of x is equal to 3x squared plus 5x minus 4. And sketch the graph. Three. So the inequalities 1, x plus 1 is less than 4. 2, 3, x minus 2 is greater or equal to 5. 3, x plus 1 over 2x is less or equal to 1. Solutions. So we don't have any previous slides. If you mean from the other class, then that one might be sent late. Question 1, part 1. F of x is equal to 3x plus 4. To redefine, you say you pick this as it is inside here. You write it first, comma, the same way it is inside here. You write it again here and put greater or equal to 0. Then you put a negative and copy it the same way it is inside here. 3x plus 4, close, comma, the same way it is appearing here. 3x plus 4 less than 0. Then you solve for this inequality. So what is 3x plus 4 greater or equal to 0? Take this to the other side. You have 3x is greater or equal to negative 4. Divide by 3, divide by 3. So x is greater or equal to negative 4 over 3. This we now bring here and say, so to redefine, we'll have 3x plus 4 when x is greater or equal to -4/3. Then you expand this, get -3x minus 4. When x you put less than this same thing that is here, -4/3. That's all.
That's the answer.
Yes.
So, on the second equation of 2x plus 4 less than 0, why are we not putting less than or equal to 0?
Because I will put the equal on top.
All right.
So could you please start again on the solution?
So whenever I ask to define, you get what is inside the modulus. You write it up here. The very thing, you write it here, greater or equal to 0. The second step, you put a negative and copy the whole thing that is inside the modulus. You put it inside the brackets too. Then on the right here, you don't write this. You write what is already on top here, the way it is appearing. Then solve the inequality, then put here. Part 2, h of x minus 1 plus x plus 3. So here, you get the first one and redefine it. There we are redefining this one here. So you say x minus 1 in the modulus is the same as you open, you write x minus 1, comma, x minus 1 greater or equal to 0. Then you write negative x minus 1, comma, x minus 1 less than 0. This becomes x minus 1, comma, x greater or equal to 1. You expand, you get negative x plus 1, comma, you get this one here. Now you're saying x is less than 1. You leave this one, you get another one, x plus 3, and say this is x plus 3 as it is, comma, when x plus 3 is greater or equal to 0, minus x plus 3, comma, when x plus 3 is less than 0. This is x plus 3, comma, when x is greater or equal to -3. Then you expand negative x minus 3, comma, when x is less than -3. Then,
So
hello,
isn't the 3 supposed to be positive in the last equation?
when it goes the other side, it becomes negative.
Oh, because of x is negative. All right.
The statement used is not correct.
Or because it's in the modular?
So we are solving this and this. So if you are solving x plus 3 is greater or equal to 0, when you take this x other side, you get x greater or equal to -3. This is the only reason why it is -3.
Oh,
Yes.
all right.
Then you put a number line, pick the number -3 and the number 1. And then you're saying when x is greater or equal to 1, here, going this side, this function is defined as this piece, x minus 1. And when x is less than 1, not including it, going this side, this function is -x plus 1. The other thing is you come to 3. When x is greater or equal to -3, here, going this side, going this side, this function is x plus 3. And when x is less than -3 going this side, the function is -x minus 3. So now we are saying the whole function h of x is going to be open 1 when x in this interval here, when x is less than -3. The second interval is between -3 and 1. So when -3 is less or equal to x, it will be less than 1. And then the last interval is from 1 going to infinity. So when x is greater or equal to 1, what do we have? So on the left interval, we have these functions. So to add them, so we have -x plus 1 minus x minus 3. So we add each line that is there. Then in the middle here, we have these two lines. We add them again, -x plus 1 plus x plus 3. Then on the right, here, we add x minus 1 plus x plus 3. So that we simplify now, -x minus x, we get minus 2x minus 2 when x is less than -3. -x plus x, that is 0. 1 plus 3, we get 4 when -3 is less than or equal to x, which is less than 1. X plus x, we get 2x plus 2 when x is greater or equal to 1. We have redefined the function.
Sam, can you for the previous? All right, thank you.
Plus 5x minus 4. That is question 2. Complete the square and sketch. To complete the square, factor out the 3. As you factor out 3, you're dividing into the remaining numbers there. So I divide 3x squared divided by 3. I get x squared plus 5x divided by 3. I get 5 over 3x plus I get this number 5 over 3 and multiply it by half. So it becomes 5 over 6. So I have it here 5 over 6. I square it minus 5 over 6. I square it. Then I get back to the quadratic, negative 4 divided by 3. Close. So you factor out 3 and then divide the coefficient of x by 2. Square it and subtract. Then we have 3. You pick this x. Then you pick this number here. Squared, we ignore this one. Then minus 5 squared, that's 25. 6 squared, that's 36. Minus 4 over 3. This is 3x plus 5 over 6 squared, 36 down. So we have negative 25 minus 3 into 36, 12. 12 by 4, we get 48. Which is 3x plus 5 over 6 squared minus 25 minus 48, that's 13, 6, 7. So I get 73 over 36. Then we expand, we multiply throughout by 3. We'll get 3x plus 5 over 6 squared minus 73 over 12. Then we say, as we want to sketch, A is equal to positive 3, which is bigger than 0. So we have a minimum turning point at negative 5 over 6, comma negative 73 over 12. And then we have the y-intercept, which is 0, comma negative 4. Then the x-intercept, you equate this whole thing to 0. So we have 3x plus 5 over 6 squared is equal to 73 over 12. You divide by 3, you multiply by 1/3. So we get x plus 5/6 squared is equal to 73/36. Then you square root. So we get x plus 5/6 is equal to plus or minus the root of 73/6. So x is equal to -5/6 plus or minus the root 73/6. Why is it negative in the turning point? Because you equate this to 0 and so for x. So it will go the other side as a negative number. So we have turning point -5/6, comma -73/12 here, and then is touching at -4. To go up like this. This is -4. Then here, -5/6 plus root of 73/6. So the other one will be -5/6. Will be -5/6 plus. Where do I put it so there's no confusion? Right on top, -5/6 plus root of 73/6. When does the graph attain the maximum turning point? When a is less than 0. When the coefficient of x squared is negative. For the turning point, you equate, for the x coordinate, you equate the inside of the square to 0. So you equate x plus, if you equate x plus 5/6 to 0, you get x is equal to -5/6. This is the value that we use on the turning point. I must assume that you are asking just to confirm what you've been doing right. All right. That is how you sketch. Should they say find the range? If it has minimum, you start from the minimum all the way up close to infinity. Include the minimum. Should they say find the max, find the minimum value? So the minimum value is going to be -73/12. Find the line of symmetry. Line of symmetry, x is -5/6. Show the line of symmetry. You put dot, dot, dot here. This is the line of symmetry. solve x plus 1 less than 4. Yes, whatever you call q, the minimum value is always that the arm that is standing alone. Then, to solve this inequality here, you remove the absolute by putting plus or minus x plus 1 less than 4. And then you say plus x plus 1 less than 4. Or, in fact, here you say and negative x plus 1 less than 4. Then x will be less than 3 and negative x minus 1 less than 4. So negative x less than 5 divided by negative 1 divided by negative 1. So you get x greater than negative 5. Then you write now the solution set is equal to, I'll start with negative 5. This one is negative 5 is less than x, but x is less also to 3. This is the solution set. Just keep in mind that every time we divide by negative, inequality will change. Inequalities of this nature, don't use the table. When you have a product or a fraction. We have another one here. 3x minus 2. 3x minus 2 greater or equal to 5. So you say, if I divide by 3, I divide by 3, because 3 is positive, nothing will change. 2 greater or equal to 5 over 3. Then plus or minus x minus 2 greater or equal to 5 over 3. So have x minus 2 greater or equal to 5 over 3. Or negative x minus 2 greater or equal to 5 over 3. This one, x is greater or equal to 5 over 3 plus 2. So we get x greater or equal to 11 over 3. The other side, negative x plus 2 greater or equal to 5 over 3, which is negative x greater or equal to 5 over 3 minus 2 over 1. This is negative x greater or equal to negative 1 over 3. Divide by negative 1, divide by negative 1, x is less or equal to positive 1 over 3. So the solution set is going to be x less than, that is negative infinity, up to 1 over 3, x greater, so that is union 11 over 3 up to positive infinity. If you can't form the intervals, then you write solution set is x a real number such that x is less or equal to 1 over 3, or x is greater or equal to 11 over 3. You close like that. And x plus 1 over 2x x plus 1 over 2x less or equal to 1. X plus 1 over 2x less or equal to 1. For inequalities, you don't cross multiply. So you have x plus 1 over 2x minus 1 less or equal to 0. 2x down, you get x plus 1 minus 2x less or equal to 0. So we get negative x plus 1 over 2x less or equal to 0. Then you get critical values. Negative x plus 1 is equal to 0. So x is 1. 1. 2x is equal to 0. So x is 0. 2. Then you form a table. 0, 1. Like this. And then block. Block. So we have negative x plus 1. We have 2x. And then we have negative x plus 1 over 2x. A number less than 0, negative 1. In between, half, equal 2. You substitute for the first one, you get a plus. It was negative, negative, you get a positive. Down, you get a minus, that is 2 times negative 1. You divide, you get minus. The negative half plus 1, you get plus. Then 2 by half, you get plus. Then plus times plus, you get plus. You put negative 2 plus 1, you get negative. 2 times 2, you get positive. Negative times positive, you get negative. We want less or equal to 0, so the solution set is going to be here and here. So you have from negative infinity up to 0, but because 0 is coming from the denominator, you don't include it. Union from positive 1 up to positive infinity. You include 1 because 1 is coming from the numerator, and we are allowed to have 0. So we include such a case when we can have 0. And I guess this is enough for the night.
Yes, it is.
All right. So you go through, we've done so much here. Go through. Tomorrow, the revision continues.
Sir, is it always you want to find
Use it.
number line?
When you are redefining.
Yes.
Yes. Tomorrow it will be a bit earlier. It won't be in the night, so it will be a bit earlier so that you can rest in the night.
So I'm asking for a previous slide.
So have a good night.